Good day, everyone. Today I'll be talking about my presentation will be on the topic fluid properties, mainly on viscosity, specific heat capacity, and thermal conductivity. So, what is fluid properties? Fluid properties describe how liquids and gases behave under different conditions such as flow, pressure, and temperature. Key traits include density, viscosity, compressibility, surface tension, and thermal conductivity, and much more. These properties infect systems like pipelines, pump, and aircraft. Understanding them helps optimize performance in industries like aerospace, hydraulics, and biomedical engineering. So, what are fluid properties and the definitions of them? For viscosity, measures a fluid's resistance to flow determined by internal friction between molecules. Thick fluids like honey have high viscosity and flow slowly, while thin fluids like water have low viscosity and flow easily. It's crucial for lubrication and fluid transport. Next, specific heat capacity is the heat needed to raise the next temperature of 1 kg of a substance by 1 degree Celsius. It's an intrinsic property. Water, for example, has a high specific heat, making it important for climate regulation and energy storage. Thirdly, thermal conductivity measures a material's ability to conduct heat. Heat flows through molecular vibration from hotter to cooler regions. Metals have high conductivity, while insulators have low conductivity. So, next up is the applications in engineering. Viscosity, for example, in chemical and food processing, affects mixing. Knowing it helps design efficient mixes, saving energy and reducing wear. In aerospace, oil and gas industry, it changes under extreme heat and pressure. Understanding viscosity ensures reliable performance in harsh conditions. Next up is the specific heat capacity. High specific heat materials, for example like water, store and release heat efficiently, improving energy use. Specific heat affects reaction material and speed. Proper material selection ensures proper temperature control, maximizing output and safety. And for thermal conductivity, high thermal conductivity materials like copper, aluminium, enable fast heat transfer, used in HVAC, power plants, and reactors for efficient cooling or heating. Affects heat transfer in reactors and storage tanks. Proper material choice ensures safety and energy efficiency. Next up, we'll identify a few conflicting engineering issues and also find ways to resolve them. So first up, the main issue, like one of the main issues in viscosity is thick fluids with high viscosity need more power to pump, requiring stronger pump and bigger pipe. One of the solutions would be using positive displacement pumps. For example, like having gas, rotary wave, and peristaltic instead of centrifugal pumps. They handle thicker fluids better by moving fixed amounts per cycle. And next up, for specific heat capacity, the main issue would be low heat capacity materials heats up fast, which indicates damage risk, while high heat capacity absorbs heat but releases it slowly, which faces an overheating risk. The one of the solution that can be used is using composite materials, for example, like metal ceramic mixes, to balance heat absorption and dissipation. And lastly, for thermal conductivity, one of the main issues faced is poor heat transfer in polymers limits cooling. Modify One of the solution would be modifying surfaces to improve filler polymer bonding and using conductive fillers, for example, graphene, carbon nanotubes, metal particles to create better heat pathways. So that is all for my presentation today. Thank you so much for listening.